Today I'll be presenting phase 3 of my biotech project. For my biotech project, I focused on benzodiazepines, and the first topic that I'm going to dive into is what exactly are benzodiazepines used for. They're used for a variety of disorders such as mental health disorders and psychiatric disorders like seizures, anxiety, and whatnot, and they can also be very, very helpful for stuff like surgical sedation as well, like if you get your wisdom teeth pulled out or something. Now, what exactly do benzodiazepines do? Benzodiazepines are essentially tranquilizers or sedatives, where within the neurons of the brain, they reduce the amount of times that the nerve fires. So, in order to explain this, right here I have an action potential graph. So, normally, without taking the benzodiazepine, and even just with GABA itself, which is a natural inhibitory chemical within our brains, the neurons fire specifically at plus 40 MV, or else they do not fire at all, and that's usually caused due to stimulus and whatnot, which is normal. And we first start off with depolarization once the stimulus has been activated, and then once it reaches the top, it then goes through depolarization. And then after that, it reaches a state of hyperpolarization where it's very, very, very negative and it cannot fire in the meantime. Then it'll go back to its resting state. Now, what benzodiazepines do in combination with GABA is that they're going to increase the state of hyperpolarization and reduce the neurons from firing as much. Now, over here, we have our graph, drawing. And this is of a neuron. So this is the cell wall that I have here, and this is the GABA pore complex. Now GABA naturally binds to this, and it acts as an inhibitory chemical. And the normal pore rate, think of it as going like this, open and closed, allowing Cl- ions to go through into the nerve, causing this hyperpolarization. And GABA is naturally occurring, as I said. Now, when GABA is complemented with a benzodiazepine, the benzodiazepine is a positive allosteric modulator for the alpha subunit here. And what it's going to do is that it's going to increase the frequency that the pore opens and closes, allowing more Cl- to get into that, causing more hyperpolarization. Now, barbiturates, on the other hand, act on a variety of different of these subunits, and what it does is that it actually increases the duration of the pore being open. So it's not the frequency that it opens and closes, but it's the duration at which the pore is open for that increases. Now, what's particularly dangerous about barbiturates is that they do not require the natural GABA to complement it. So, and it can actually mimic GABA on its own. So when taken in excess, instead of a benzodiazepine per se, will cause like sedation and whatnot, an overdose of a barbiturate can be extremely, extremely deadly because the pore is simply open and a bunch is going through, and if too much is sedated within the brain, things start shutting down, like respiratory depression and coma, as being some of them. In terms of the first benzodiazepine that was ever discovered, the first one is chlorodaz epoxide, otherwise known as Librium, where it was discovered as a mistake in 1955. And it was only until in the 1970s where they actually discovered how bad benzodiazepines really are in terms of addiction, in terms of misuse. Before then, it was touted as a miracle drug. Now, in terms of like how they're made, there's a variety of different steps to go through it, but I'll focus on the technology part because I received the feedback before from Charles, and I should definitely focus more on the technology aspect as well in my video. So, here we have chromatography, which is commonly used for benzodiazepines to purify and kind of like separate the side reactions or bad things that we do not want within it So the way it works is that you run the substance through the silica gel, and it will separate out the contents that are not desirable or the ones that you're not looking for. Now, the reason why I picked this topic in particular is because it's been absolutely revolutionary for my mental health journey, in terms of treatment, in terms of my anxiety, in terms of borderline personality disorder, it is absolutely amazing. That being said, at this point within my mental health journey, I'm at a point where I have to withdraw from benzodiazepines, and as I mentioned, I think in the research component, with benzodiazepines, it can be deadly to withdraw from them because the brain adapts and tolerance builds from them, which is why benzodiazepines are very, very strict in legislation, and in the United States, it's a level 4 controlled substance because of its potential for misuse and death. Now, in terms of the benzodiazepine, the way to withdraw is to taper the dose slowly until your brain naturally adjusts. Because if you suddenly take it away, it can lead to seizures and stuff. Now, how it actually works for treating seizures is that it inhibits the neurons more within the brain, causing everything to sort of slow down and essentially stop the seizure from happening, because the seizure is too much activity within the brain causing convulsions and whatnot.